Let's review from the last few modules. What does it mean to solve an equation when there is one variable in the equation? Like this one, for example, 3x minus 4 equals 12. Well, if we got that problem on our last test, we would just start solving. We'd start undoing what was done to the x until we got an answer. When there's one equation and one variable, you're going to get one answer. In our case, x equals 5. What we're going to talk about in this module is when you have two variables in an equation. Equations tell the relationship between two variables, x and y. We are going to explore what happens algebraically, meaning with the equations, and we'll also examine what happens graphically with these. There are different types of equations. In beginning algebra, we focus on linear equations, equations that make straight lines. If you go on to higher algebra, college algebra, you'll deal with other types of equations that are nonlinear. Here's an example of a quadratic, which is nonlinear. But for beginning algebra, we will stay focused on linear equations, and I'll talk about what that means. At the top of the page, when there was one variable, we found one solution. When there are two variables in an equation, there will be many different solutions. So what does a solution look like? A solution is an ordered pair where the x and y coordinates make the when you put it in for x and y into your equation, make a true equation. So one question that you'll be asked quite a bit in your homework is this ordered pair a solution to a particular equation? Here's how you check. Is the point negative 3, 6 a solution to y equals negative 2x plus 1? The first number is the x coordinate, and the second number of an ordered pair is the y coordinate. So we're going to replace the y with a 6 and the x with a negative 3. Since the negative 2 and the x are right next to each other, multiplication is implied. So let's check and see if this is a true equation. We have a 6 on this side. Negative 2 times negative 3. A negative times a negative is a positive. So that'll be 6 plus 1. So I get 6 equals 7. No, that is not true. So therefore, negative 3, 6 is not a solution to the equation y equals negative 2x plus 1. Let's check the point negative 3, 7. Again, negative 3 is the x coordinate, 7 is the y coordinate. So 7 equals negative 2 times negative 3 is a positive 6. 6 plus 1 is 7. So yes, this is a solution to our equation. Another connection with this is how all of the points that are solutions to this line look graphically. So we're going to start out by graphing this solution, the one that we know is a solution to our equation, on the line, negative 3, 7. So you go to your x-axis and find negative 3. Go to your y-axis and find 7. And at their intersection point, you make a dot. That's the point, negative 3, 7. Let's see if we can find more solutions to this equation. When I'm in class, I make students play around to find x and y pairs that will make this equation true. One thing that students sometimes do is start with an x coordinate and try to find the y coordinate that would go with that particular x coordinate. So if we have y equals negative 2x plus 1, If we know that the x-coordinate is 2, we can find the corresponding y-coordinate. So when I subbed 2 into my equation, for x, I got out a y-coordinate of -3. That means that the point x is 2, y is -3, is a solution to my equation. Let's do another one. How about if the x-coordinate were 0? What would the y-coordinate be that went with that one? Well, if I replace the x with a 0, 2 times 0 is 0. The y-coordinate will be 1, so that means the point 0, 1 is also a solution to my equation. Let's do another one. How about if the x-coordinate were -2? What would the y-coordinate be? The y-coordinate would be 5. There's another solution to my equation. So if I graph it, x is -2, y is 5. I'll get a point right here. You might notice that there seems to be a pattern to my solutions. All the solutions that I've come up with so far are on this line. We'll see how straight of a line I can draw. And it's true, all the solutions to y equals -2x plus 1 will be on this line. Now I've centered on whole number solutions, but there are other solutions. Anything on this line is a solution to this equation. Some other examples, -1, 3, right here. Another one, 1.5, -2. So x is 1.5, y is -2. Another one, a fraction example, 1/3, 1/3. X is 1/3, y is 1/3. My line isn't very straight, but it's right about there. Anything on this line will make this equation true. That's why we call this type of equation linear. We will study what that means a little bit more next module. But to be linear means that your equation looks like this and that your solutions form a straight line. So how many solutions are there to this equation? Y equals -2x plus 1. There's infinitely many, but they're all located right along this line. Consider the equation y equals 4x minus 5. What will a solution look like? A solution will be an ordered pair that has an x-coordinate and a y-coordinate, where those numbers, when subbed in for x and y, will make a true equation. Types of problems that you'll see in your homework will look like this. They will just be yes or no questions asking, is this ordered pair, this point, a solution to y equals 4x minus 5? So sub in. -1 is your x-coordinate, -9 is your y-coordinate. Sub those in for x and y. I come up with a true equation. So yes, -1, -9 is a solution to y equals 4x minus 5. The point -1, -9 would also be on the graph of the line of this function, this equation. Let's look at the next one. Is -2, 7 a solution to y equals 4x minus 5? The x-coordinate is 2, the y-coordinate is 7, sub in. I don't end up with a true statement. I end up with a false statement, so no. The 0.27 is not on the graph of this line, and it does not satisfy this equation. It's not a solution. Next one. Is 5,3 a solution? Again, sub in. We don't end with a true statement, so no. This point is not a solution to the equation y equals 4x minus 5. What this problem is asking is to now find the solutions, and they give us the x-coordinates. They tell us the x-coordinates are -1, 0, 1, and 2. They want to know the y-coordinates that go with those. Show them in a table and on the graph. So let's do the first one. When the x is -1, what will the y be? Well, use your equation. Y equals 4 times -1. I'm just subbing the -1 into my equation instead of x. 4 times -1 is -4. Minus 5 is -9. So the point -1, -9, it'll be down here off my graph, is a point on my line. You do the next ones. Stop the tape now and do them, and then unpause to see if you've gotten the answers right. After you've done the arithmetic, found the ordered pairs, and plotted your points, you can see that this equation has a corresponding linear graph that looks like this. Every point on this line will be a solution to y equals 4x minus 5. Next module, we will talk about the patterns, some of the patterns that you see here, and how to use some of those shortcuts to graph a line more quickly without plotting all these points. For example, you'll notice this point right here. Any time that you make the x-coordinate be 0, this number right here will be the y-coordinate. And that's one pattern that we'll talk about next module. Not all equations in mathematics are linear, straight lines. In beginning algebra, we focus primarily on straight line, linear equations and graphs. If you go on to higher algebra or college algebra, you'll deal with some of these types of equations. This is a quadratic equation because of the x squared. This is a cubic equation or a polynomial because of that exponent. This is a rational equation because of the x's within a fraction. This is a radical equation because of this square root. We will be dealing primarily with linear equations. Next module, we'll talk more about what makes a linear equation and what forms they can be in. But I want you to know that there's other things out there too.